So we are told that the point -1, -4 is on the terminal point of an angle in standard position. So if I were to draw that out, -1, -4, that point is on the terminal arm of some angle theta in standard position. We want to find all of the exact trig ratios for theta. So in other words, we want to find out what sine of theta, cos of theta, tan of theta, plus the reciprocals, cosecant of theta, secant of theta, and cotangent of theta. In order to do this, we have to use our knowledge of reference angles and trigonometry. First of all, if that's the angle theta, can you see that this angle right there would be our reference angle? Why do we learn reference angles? Because sine, cos, and tan of the reference angle will be the same ratio as sine, cos, and tan of the actual angle. The only difference is you have to know if it's going to be positive or negative depending on the quadrant. So what I'm going to do is I'm going to use that reference angle and I'm going to draw a triangle. So we always draw a triangle with our reference angle. So our triangle always goes back to the nearest x-axis. And we label as many things as we can on this triangle. So I've got a reference angle. Does it make sense that this length is going to be 1? That this length is going to be 4? How long is the hypotenuse of that triangle? Square root of 17. You will get really good at doing a squared plus b squared equals c squared in your head. 4 squared plus 1 squared is 17. So our hypotenuse is the square root of 17. So on that triangle, can you see that sine of our reference angle, opposite over hypotenuse, would be 4 over root 17? What that means is sine of theta is also going to be 4 over root 17, but because it's in quadrant 3, it's going to be negative. And cos of theta is 1 over root 17. And tan of theta, well, and cos of theta in quadrant 3 will also be negative. So again, we are using our cast rule. And because our point is in quadrant 3, we know between sine, cos, and tan, only tan is going to be positive, opposite over adjacent. Once you have all of your primary trig ratios, sine, cos, and tan, to figure out your reciprocal ratios, all you have to do is write the reciprocals. And you have secant, cosecant, and cotangent. On a multiple choice question, if they asked you to find cos of theta, why would the answer be this? What's happened? Because according to our green numbers there, we have -1 over root 17. But in the multiple choice, they would have written it as negative root 17 over 17. Can't have a square root on the bottom. That's, remember, rationalizing the denominator. So you would multiply by square root of 17 on top and square root of 17 on bottom to rationalize the denominator. That's something you always had to do in grade 11. In grade 12, they assume you know how to do that. So the only place that it will come up in this rationalized form is in multiple choice questions. They'll have the rationalized form. But when you're asked to write out, if they just say, what is cos of theta? and you leave your answer as negative 1 over square root of 17, you will lose no marks for not rationalizing the denominator. So you're allowed to not rationalize the denominator in grade 12. In grade 11, if your final answer was 5 over 10, you would have lost a half a mark. Why? Didn't simplify, right? That's easy to simplify. It's 1/2, right? In grade 12, they assume you know how to simplify. So if you leave something as 5 over 10, they'll give you full marks. But in a multiple choice question, they'll probably list it as 1/2. So you've got some nice things now in grade 12. They're not going to deduct marks for not simplifying or for not rationalizing the denominator. Okay, questions for this one? Just number 8. And we will leave example 4 for tomorrow.